let's talk about different type of functions. So first, let us talk about identity function. So what is an identity function? Suppose this R is the set of real numbers. Suppose f be a function from R to R, that is from the set of real numbers to set of real numbers, defined as f of x is equal to x for all x belongs to R. That is, the function f takes x to x. So it is taking an element from the domain. Suppose this is an element x from the domain and this is our codomain. So this function f takes this x in the domain to x in the codomain. So this function takes an element to itself. So it is called an identity function. Now let's see how we can draw the graph of this identity function. So for drawing the graph, first let's draw a table. So in the table, we will write the values of x, and for that we will write the values of y. So we are taking x from the set of real numbers. So let's take x as -2. Then what is x? So what is y? So from the definition of this identity function, we get f of x equal to x. So f of -2 is equal to -2. So that means, so our y is actually f of x. So we get when x equal to -2, y is also equal to -2. So y equal to -2. So if you take x equal to -1, then f of -1, that will be -1. So our y is also equal to -1. Similarly, at x equal to 0, y is 0. At x equal to 1, y is 1. At x equal to 2, y is 2, and so on. Now let's draw the graph. So in this table, we get the values of x and y. So let's draw the axis. So this is our x-axis and this is y-axis. Now in this axis, suppose this is 1, 2, 3, 4 and so on. Here we have -1, -2, -3 and so on. And also here we have 1, 2, 3 like this, and here -1, -2, -3 like this. So let's plot the point. Let's plot the point -2, 2. Sorry, -2, -2. This point is somewhere here. Then plot the point -1, -1. So this point is here. Then plot the point 0, 0. This is our origin. So this point is 0, 0. Then plot the point 1, 1. So here is the point 1, 1. Then here is the point 2, 2. Now join all these points. So when you join all these points, this is not accurate, but when you join all these points, you will get a straight line. A straight line. So we will get a straight line like this. So let's do this in Desmos. So you will understand. So our function is fx. So fx is equal to x. So you see here we get a straight line like this. So this is our identity function. Now let's see what is constant function. So suppose f is a function from the set of real number to set of real number, defined like this. Fx is equal to c for all x belongs to R, where c is a constant. Then we call this as a constant function. We can take c as anything. Suppose you take c is equal to 2. Then the function will be fx is equal to 2. That is, for all values of x, the function takes only the value 2. So if we draw this is our domain, set of all real numbers, and this is the range, set of all real numbers. So these are some points of this domain where this all goes. So this is 2 in the codomain. So all these points in the domain goes to 2. Every point in the domain goes to 2. So this is the constant function. So what is f of 1? F of 1 will be 2. What is f of 2? That will be 2. What is f of 3? That will be 2 also. F0, that will also be 2. Then if I say f of minus 1, that will also be 2. So f of 1.5, that is also equal to 2. So whatever value you take from the domain, every value will go to 2. So this function is called constant function. So now let's see how the graph of constant function looks like. So again we are drawing the x-axis and y-axis. So we will draw this function fx is equal to 2. So again you can make the table for your convenience. So take any values of x, suppose 1, that also goes to 2. 2 goes to 2. 0 goes to 2. Minus 1, that goes to 2. Minus 2, that also goes to 2. Now we will plot these points. So this is 1, 2, 3. Minus 1, minus 2, minus 3. Here is 1, 2. So 1 goes to 2, this point. 2 goes to 2. Then this is 0. 0 goes to 2. So we get a point here. Again, minus 1, that also goes to 2. Minus 2, that also goes to 2. So every point goes to 2. So that's why we will get a straight line like this, a constant line. So this is the graph of constant function. So if you draw this in Desmos, so our function is fx equal to 2. So we get a function like this. So now let's talk about polynomial function. So what is a polynomial function? So before we go about the polynomial function, we have to know what is a polynomial. So what is a polynomial? So a polynomial is an expression like this: an x to the power n plus an minus 1 x to the power n minus 1 plus an minus 2 x to the power n minus 2 plus like this a2x square plus a1x plus a0. So if I give an example of a polynomial, so 2x square plus 3x plus 7, this is a polynomial. Another example can be like x to the power 7 plus 7x to the power 4 plus 6x plus 1. This is also an example of a polynomial. Again, x square, x cube, 6x to the power 4, they are all polynomial. So what is a polynomial function? So when we define a function f from R to R is defined as fx is equal to some polynomial. Suppose a0 plus a1x plus like this an x to the power n for all x belongs to R. So when a function is defined like by a polynomial, so then it is called a polynomial function. So I can give an example like this: fx is 2x square plus 4x plus 1. This is a polynomial function. Another example we also can give like this: gx is equal to x to the power 4 plus x cube plus x plus 1. This is also a polynomial function. So let's try to draw the simple polynomial function. So we can tell if x equal to 1, that is also can be seen as a polynomial function. How? Because we can tell that it is 0 into x to the power n plus 0 into x to the power n minus 1, like that, 0 into x plus 1. So we can tell it as a polynomial function. So now let's try to draw the simple polynomial function fx equal to x square. So first what we do, we again do the table xy. So take x equal to 1, then y is 1. So x equal to 2, then y is 4. X equal to 3, we get y is 9. For x equal to 0, y is 0. X equal to minus 1, y is 1. X equal to minus 2, y is 4. X equal to minus 3, y is 9. So using this table, we can try to draw this polynomial function. So this is x-axis, y-axis. So if you plot this, you will get a graph like this. So this is called parabola. Let's do it in Desmos. So we have fx equal to x square. See, we get a graph like this. Now what will be the graph of, suppose we have a polynomial function gx equal to x cube. So this blue line, this is the graph of gx equal to x cube. Now let's see some complex polynomial function. Suppose hx equal to x to the power 4 plus 5x cube plus 6x plus 3. Suppose this is a polynomial function. How does it look like? It looks like this. So it looks like this. You can try many polynomial functions using Desmos. Okay. Now, so we are done with the polynomial functions. Now let's do rational functions. So what are rational functions? Rational functions are functions like of the form fx by gx, where fx, gx are polynomials, and this function we call it as hx. So hx is defined for all x where gx is not equal to 0. So hx is defined for all these x such that gx is not equal to 0. So you can take an example. Suppose fx is equal to 2x square plus 4 and take gx is equal to x plus 2. Then what is the rational function? The rational function hx, that is fx by gx. So 2x square plus 4 divided by x plus 2. Where is it defined? Now see, when gx is 0, gx equal to 0 means x plus 2 equal to 0 when x equal to minus 2. So when x is equal to minus 2, at x equal to minus 2, gx is equal to 0. Therefore, hx is not defined at x equal to minus 2. So this rational function hx is defined from r minus 2 to r. Okay, you can use Desmos to draw the graph of the rational functions. Okay. Now we have a very common rational function that is defined as fx equal to 1 by x. So where it is not defined at x equal to 0. So what is its domain? So domain of f is equal to r minus 0. That we are excluding 0 from the set of all real numbers. So this is very common and very popular rational function. Now let's draw its graph. So we make the table x and y. So at x equal to 0 it is not defined. At x equal to 1 it is 1. At x equal to minus 1 it is minus 1. At x equal to 2 the function is half. At x equal to minus 2 the function is 1 by 2. So how the graph looks like? It looks like this. So the graph is something like this. You can plot as many as points you want and you will get a shape like this. Also you can plot this in Desmos. So let's plot if x is equal to 1 by x. So you see we get a graph like this. Okay. Now you have modulus function. Modulus function is very important. So how this modulus function is defined? We define it like this. Fx is equal to x if x is greater than or equal to 0, and fx is equal to minus x if x is less than 0. So it has two conditions. So when x is greater than or equal to 0, fx is x. So suppose we take x is equal to 2. Then what is fx? So f of 2 is equal to, so from the definition you see fx is equal to x. So f of 2 is equal to 2. Why? Because this 2 is greater than 0. So we take another example. Suppose we take x is equal to 3.4. Now tell me, is this 3.4 greater than 0 or not? So we see that 3.4 is greater than 0. That's why f of 3.4, what will be it? So definition says if x is greater than 0, then fx will be x. So 3.4 is greater than 0, therefore f of 3.4 is 3.4. Similarly, if you take x is equal to root 2. Now we know that root 2 is greater than 0. Therefore, f of root 2 will be root 2. Now, let's see what happens for the negative x. So, the definition was f of x equal to x if x is greater than equal to 0, and that f of x equal to minus x if x is less than 0. So now we have let's take negative x. So suppose we take x equal to minus 1. So minus 1, that is less than 0. So we will see this. X is less than 0. So minus 1 is less than 0. So f of minus 1 will be what? This x is less than 0. So the value will be minus x. That means minus of what is x? X is minus 1. So minus of minus 1. That means we get 1. Again, let's take x is equal to minus 4.6. So this is also less than 0. So we see when x is less than 0, when x is less than 0, x goes to minus x. So here x is less than 0. So f of minus 4.6 will go to minus of what is x? x is minus 4.6, so it will go to minus of minus 4.6, so we will get 4.6 only. Similarly, when x is minus 3, f of minus 3 is equal to 3. So observe one thing, by this absolute function we only get the positive values. So absolute function always gives us positive values. So f of 2 will be 2, f of minus 2 will be also 2. So let's draw the table x, y. So 1 goes to 1, 0 goes to 0, minus 1 also goes to 1, minus 2 goes to 2, 2 also goes to 2, like this. Minus 3 goes to 3, 3 also goes to 3. So this absolute function always gives us positive values. So let's draw. If we draw this, you can plot the points in the table. So when you plot this, you will get a shape like V. All the y values are positive. This is the graph of absolute function. Let's try to draw this in Desmos. So our fx, if x is equal to mod x, you see we get a V-like shape. Okay. So in this video, I am ending this video here. So these are our special type of functions. There are identity function, then what we studied the constant function, then we studied polynomial function, then rational function, and then we studied this absolute function. There is another type of function, that is step function. So we will talk about that later. Thank you.